Hey, and welcome to this mini course on gut health. This course is for anyone who wants to know how their gut works, that wants a little bit more information about understanding what does the phrase gut actually mean, right? What uh what is the gut? How does it function? Or like how does the digestive system work? Or at least how is it supposed to work? So whether or not you're a science person, I want to go over in the next 20, 30 minutes dive into that, right? So like if you're like, hey, look, I haven't taken any science class since high school biology, totally fine. If you're like, hey, I'm a total science nerd, great too. This is supposed to be for either one of those people, right? I want you to have a full understanding of like, all right, this is how our gut works. This is how it's supposed to function so that you can understand your body a little bit more. So let's dive in. The first thing we're going to do is we're going to talk about the digestive system, right? Because we have to ask the question, like, what is the gut? And like the gut is part of our digestive system. So we're going to start all the way at the top and we're going to start with your mouth. Okay. So in your mouth is actually where digestion starts. So most people don't actually think about that, but that is where it starts. Okay. So we have both mechanical digestion. So what that means is actually chewing. So we have to physically or like mechanically break food apart so that we can start the digestive process. You can't just like swallow a whole steak, right? You got to break it down. And then there are also enzymes that are at play here. So what does that mean? So this is a chemical digestion. So we have different enzymes, different particles that basically come in and they start breaking down certain things within our mouth. All right. Specifically, they get carried in our saliva. So there's what's called salivary amylase. So this is something that actually it's in our saliva. When you start chewing things that contain carbohydrates, it'll actually start to break down those carbohydrates right there in your mouth. All right. So before you've even swallowed it. Once the food leaves our mouth, right? Where does it go? It goes down to our esophagus. So our esophagus is the pathway that goes from like our mouth down to our stomach. And what's interesting about it is it's like just a tube, but there's what's called a sphincter on both ends. So a sphincter is like a circular shaped muscle, right? So a lot of times they'll go like this, so you can kind of have an idea. When it like contracts, it'll squeeze and like clamp essentially. And then when it relaxes, it essentially opens. So that's what we have in our esophagus as that food travels all the way down, right? And so when that happens, the sphincter actually is like the gatekeeper. So it can either like help things travel or keep things like staying put, right? And so we'll see this throughout our digestive system. And this is the first time that we actually see it in our digestive system is it starts, so we have a sphincter at the top of the esophagus and then again at the bottom. So what's next is the stomach. So we have the food in our mouth, travels down our esophagus, it gets to our stomach, all right? And then a bunch of things happen in our stomach. It's a little bit more sophisticated, all right? So what happens? There are three main things that are going to happen once we get to our stomach. So the first thing, so we're going to see both chemical digestion and mechanical churning as well. So like similar to the mouth, but a little bit more intense and a little bit more elaborate. So the acid, so right, is most people know of like stomach acid. So the acid is going to play a couple of roles, right? So one, it helps to break things apart, which most people know if you put acid on things, it's going to break things apart. But then also it's going to serve as a protection because the acidity of our stomach is so low that acid actually helps to kill off some bacteria and pathogens in and of itself, all right, that come in contact with the food. Then we see the antrum. So the antrum is the lower part of the stomach, and that actually like churns and grinds food into, so like there's like a churning movement essentially that will mix food and digestive enzymes and that acid together in that digestive process, right? And then we have what are called enzymes. That's all mixed up in that whole process, right? So when food mixes with the acid and the enzymes and makes this like slurry of things, it's actually called chyme, which is a pretty disgusting word in my opinion. But that's what it's called. And it like shakes all around in the antrum of your stomach, in that bottom part of your stomach, right? So what do enzymes do? So the enzymes, again, the things that kind of like break apart certain foods, we'll see that. So there's pepsin, which is an enzyme that starts to break down proteins. And then we'll also see what's called gastric lipase. Gastric means stomach, and then lipase breaks down an enzyme that breaks down fat. So we see fat and protein start to get broken down a little bit more in our stomach. So that's where digestion starts with them, right? From a chemical perspective. So the next stage we'll see is that after that food leaves your stomach, it's going to go into your small intestine. So I'll say this, most of the time when people talk about their stomach, they're probably talking about their small intestine because like it's right here. Like your liver is up here, your stomach is over here, your small intestine is like basically right here. So most of the time when people are like, oh, my stomach, they're probably talking about their intestine. I don't correct them because who cares? But that's physically where it is. I used to work in the hospital, and I used to do that all the time when I would talk to people. Is I'd be talking about body parts. I'd be like, your stomach, your intestines, because I think it's important to like see and kind of have an understanding where those are placed. Whether or not people like that, I don't know, but I still do that because I think it's helpful to know. But anyways, in our small intestine, there are actually 3 different parts of our small intestine, and this is where in our whole small intestine is when about 90% of nutrient absorption actually happens. That is the primary function of it. So we're going into it. So again, if we go back a little bit and you can see, so that like pink swirly thing, like the long squiggly thing, that's going to be our small intestine. The gray part on the outside is our large intestine. We'll come back to that, but for right now, we're going to focus on the pink, right? So if we take that large intestine away, this is kind of what it looks like. And we're going to go section by section. Like I said, there are 3 different parts of our small intestine. So that first part, all right, where that little box is, that's called our duodenum. Some people say duodenum or whatever, but that sounds weird to me. So duodenum is what we're going with. So in our duodenum, that first little section of our small intestine, right? So that's where a huge part of digestion actually happens. More breakdown happens. Okay. Why? Because there's a lot of different, what are called accessory organs. So like our pancreas, our liver, they actually like dump their different like juices like into our small intestine at that point, which help to kind of break down the food that's traveling through our intestines, right? So what's going to happen? We have our pancreas, which is going to produce a bunch of pancreatic enzymes. They kind of spit out into that section of it. And then our liver is going to create bile, right? And then we also store bile in our gallbladder. And so those are going to release that bile into the small intestine as well at that point, and that helps to break down fats. And so we see all of those like extra juices essentially get sprayed into our intestines that kind of sounds gross, but that's what happens, right? It goes into the intestines at that part to help to break down and release those enzymes are going to break down different parts of our food. So those are going to help break down even further the particles of our food that have made it all the way to the duodenum. The next part is called the jejunum. All right. And so this is like a super long part, that middle section of it. And so this is the main spot where nutrient absorption happens. So a lot of our nutrients actually get pulled into our intestines in this part. And primarily we'll see like carbs, fat, and protein, like they get sucked in isn't the right word, but they go into, that's where we get absorbed, right? They absorb into, and then they go in the bloodstream, then they can travel throughout the rest of our body the way they're supposed to go. The last part of our small intestine is called the ileum. All right. So it's this bottom part here. This is actually where B12 is absorbed. Fun fact. And also where we're going to like reabsorb some bile salts. So we use bile salts, right? They go in at the duodenum. We use them to break things down. We actually like recycle them, right? So we're going to reabsorb them there, then bring them back up so we can actually use them again. Here we also see what are called Peyer's patches. And so these are some sections of like lymphoid tissue. And so it actually like helps, it's like houses our immune tissue, right? So that's going to help protect against some specific pathogen, right? That's going to initiate an immune response if needed based on certain pathogens that might have still gotten through at that point. So we're going to come back to the gut immune connection, but that is one of them, right? We have these Peyer's patches that are in the ileum that help to initiate an immune response based on some of that, the pathogens that might have made it to that point. So that is what our small intestine looks like. All right. Then next, our small intestine is going to attach to our large intestine via another sphincter that we've talked about. It's called the ileocecal valve, right? So the first part of your large intestine is called the cecum. So hence the ileocecal valve, right? So the ileum connects to the cecum via a sphincter, right? And that kind of hands off what is left in the small intestine that needs to travel into that large intestine. Okay, and then we get into our large intestine. So our large intestine is going to be this like pink on the outside, right? The gray on the inside is going to be the small intestine we just talked about. That pink on the outside is going to be our large intestine. And so the focus of the large intestine is going to be, so at this point, right, we have to think about the fact that like most of the nutrients have already been absorbed, right? So the main purpose of the small intestine was nutrient absorption. So carbs, fat, protein, that all like came into the small intestine, or should have mostly come into the small intestine. Therefore, when we get to the large intestine, we're left with like waste, water, electrolytes. And so the main purpose of the large intestine is going to be reabsorbing fluid and electrolytes and getting rid of waste. All right. And so that is what's going on. And then we also see that this is where the home of the majority of bacteria actually live, right? So when we talk about our gut bacteria, our gut microbiome, right, we're talking about the microbiome that actually exists within that large intestine. So that's typically what we're talking about, because that's where the majority of bacteria is housed. So that's what we're going to kind of go into the gut microbiome. So here's what I'm saying is like, when we're talking about the gut, right, oftentimes we're referring to our intestines. So there, people can use it in a bunch of different phrases, right? Like follow your gut, right? That's different. But when we're talking about gut health, we're typically talking about your intestines. And more specifically, we're often talking about your large intestine, because that is where a lot of that's where your microbiome is housed. And so when we're talking about it, it's typically in reference, when we're talking about the gut, is small intestine or small and large intestine, right? And so we're talking about that whole intestinal structure. So when we talk about the gut microbiome, we're talking about the bacteria that actually reside in that large intestine. And so inside that large intestine, we have trillions of bacteria that are there, and they have a job to do, right? They're there intentionally, and they're there on purpose. Now, sometimes we can have what's called dysbiosis, like a things that are not the way they're supposed to be, right? We'll get to that later. But there's an intentionality of having a bunch of cells in here, right? And they're going to do a couple of things. One, they're going to help with fermentation of certain fibers to turn certain fibers into short chain fatty acids, which we want. All right. They can also help to produce like things like vitamin K and some of our B vitamins, right? And then they also can train your immune system. So we have specific immune responses that our large intestine can actually like initiate or like train our body in how to fight them. And that is a good thing. These are all things that they're intended to do. All right. A lot of times we often talk about like good bacteria versus bad bacteria, but the reality is a healthy gut is actually one that has the appropriate ratios, right? Has the right number of bacteria, the right specific bacteria in the appropriate ratios, because too much of one that might be helpful for whatever reason and too little of another, like too much or too little of anything is not necessarily great. So we want to make sure that we have the appropriate ratios, because that is what allows for a healthy gut. All right. Okay. Let's talk about the gut lining, because that's the next place we need to go. So when we're talking about the gut, right? So we have our bacteria. There's actually this layer that is in between the food and what gets absorbed. All right. So there's a single layer of cells that actually decides what gets absorbed and like what gets kept out. Right. And this is where people hear about like leaky gut. There's an issue within this barrier. So this single wall of cells is super important, because you've got this tube, right, essentially that's going down your entire digestive system with foods going through. And then we've got this layer of cells that's determining like, do you stay here? Do we get rid of you? Or is it time to like take you in, and can we actually use you within our body for whatever purpose? So that layer is like super important. So we're going to dive a little bit deeper into, all right, cellularly, what's going on. Now, bear with me. If you're like, hey, I am not a science person, understanding what's going on makes it easier to be able to deal with health issues in the future, right? Because like we can sit there and be like, there's something wrong with your stomach, there's something, but what? Because the microscopic issues typically are the ones that are going to have like big impacts. So let's go to the cellular level. Hang with me. I'm going to try to make it interesting. Well, I just think it's all interesting. But stay with me. Okay, so we've got what are called villi. So when we're thinking about the inside of our cells, right? So we've got these cells. We have these villi. So they're like these finger-like projections that stick up, right? Like they look like little weird things, and that increases the surface area. On top of that, we've got these extra little ones that are extra little fingers on top of the big fingers, right? And these are called microvilli. And the entire purpose behind this is to increase the surface area. And so we see this oftentimes, and we'll get into this, in our small intestine cells, because it increases the surface area so that when we draw in our different nutrients, there is more space to actually be in contact. So a lot of times you'll hear a lot of people say, and I don't want to get ahead of myself, like, chew your food really well. Like, why, right? Like, part of the goal during our entire digestive system is to increase the surface area of different foods we're consuming so that we can extract as many nutrients as we can out of the foods that we're actually consuming. So oftentimes people will call this, like, these microvilli, they'll call it a brush border. But again, the biggest thing is, like, can we increase the surface area? So here's the deal. There's actually a difference between small intestine cells and large intestine cells when we're looking at them this close. So when it comes to the small intestine cells, those actually have, so the villi is there, and then they have really tall microvilli as well. So the biggest thing that we've talked about is nutrient absorption. So can we increase the surface area as much as possible? So really tall fingers, really tall little baby fingers on top of the fingers, just to increase the total amount of surface area that nutrients can actually get pulled into the cell. And like I said, the biggest thing is it's built for nutrient absorption. Can we get as much in as possible? All right. So like we've talked before, so anyways, like during your whole digestive process, like, can you chew well? Can you increase surface area? And then when you get to this point, can we draw in a lot of nutrients into the cell? Then once we get to our large intestine, it's slightly different. So you can see that there are cells there, and there are going to be some microvilli, but they're going to be like smaller grooves. So the surface area is not as dramatic as it is with our small intestine cells. So small intestine cells, tons of surface area. The large intestine, there's still some microvilli. It's just a lot shallower in there because the main purpose is going to be more fluid based and getting in electrolytes versus getting in all of the nutrients, as many nutrients as we possibly can, right? And so also we'll see is that there's mucus producing cells. So that's actually like a pretty disgusting term. I don't love it. But that's what happens because the main purpose is to create a mucosal barrier of protection. So what we want to do is, like, there's bacteria that's going to be present in our large intestine, and we want it there because it serves a function and a role. But we also don't want that bacteria to get into our cells, because if it gets into our cells and then goes into our bloodstream, that can lead to an infection within our bloodstream, sepsis, all these things that are not good, right? So we need this mucosal barrier as a protective barrier to keep the bacteria where they're at, but not actually go into the cells. And so that's what we see. We have a lot of mucus producing cells to create that protection around those cells, so the bacteria stay where they're supposed to be and can serve a purpose and a function, but don't actually get into the cells, right? The main purpose of these cells in the large intestine is going to be to reabsorb fluids, to reabsorb electrolytes, and also to house the bacteria in an appropriate way so that that bacteria doesn't actually like shift into the cells though. So now we're going to go like out a little bit more and be like, okay, so we know what's going on cellularly. So how does this actually connect to the rest of our body and the rest of our cells? Because we always talk about, I think it's often said like, hey, your gut's connected to everything. It's like, sure, but how? Okay. So let's talk about some of the systems that are actually connected to your gut. Okay. First one, your brain. So your brain is actually connected to your gut via the vagus nerve. And this is a two-way communication system, right? And so that is one way that we talk about the gut-brain connection, like, is via the vagus nerve. Okay, hormones. We talk a lot about, I often hear people talk about like, hey, my gut's off. Maybe it's like hormone related and stuff. So let's talk about this. First of all, insulin and glucagon both control your blood sugars. Those are both hormones. And so they're affected by the foods that you eat or you do not eat, right? So there's one thing. Then when we're talking about sex hormones, because most of the time when people are talking about like, hey, my hormones are off, that's really what they're talking about. Like estrogen, progesterone, testosterone, like these are our sex hormones. So why is that impactful? So one of the things you have to think about is that our metabolism, the nutrients that we're able to absorb are going to affect the production of that. Specifically, when we think about things like fat, are going to actually affect the production of our sex hormones. And therefore, how your gut is functioning is going to affect your hormone levels. Okay, immune system. We've talked about a couple of immune responses, right? And so the majority of your immune cells are actually housed in your gut. And we have to think about it this way. If your gut is constantly inflamed, right? If there's an issue going on, if there's an inflammatory response, if it's constantly inflamed, then your immune system is constantly heightened. It is constantly on. And so when that happens, it's going to have an issue responding to, like, we have to think about, like, it's going to have an issue responding to other potential things within your body because it's constantly fighting already in the place that it's in. So then it's like, it has multiple things that it's going to be fighting, if that makes sense. So like having something wrong in your gut is going to turn on your immune system so that therefore, if there's another response, it's weakened in response to that secondary response that may be happening. Okay, energy production. This is actually a picture of a mitochondria. And if you don't know that, that's the powerhouse of the cell, right? That's really helpful. So your gut is going to determine how well you absorb nutrients, and your body needs nutrients in order to be able to produce energy. So whether it is micronutrients or macronutrients, our body needs both of them to be able to produce energy, and our inability to be able to absorb specific ones in specific ways is going to affect our energy production. There you go. Then a lot of times people will talk about that. Oh, my hair's falling out, my skin's flaky, my skin's whatever. So when we think about that, that is impacted by your gut. Why? Again, if we think about nutrient absorption, we need certain nutrients to be able to create these tissues, to be able to repair these tissues, to be able to strengthen these tissues. And if our absorption of certain nutrients is off, it is going to affect our ability to be able to repair, produce, and strengthen these different types of tissues, specifically things like hair and our skin, right? Okay, so that's just the beginning list. Like I can go on about all these different systems or specific parts of your body that are actually impacted by your gut. But I want you to think about the fact that like when you have brain fog and anxiety and skin issues and fatigue, like these things can all be related potentially to your gut. It's because your digestive system is not just one isolated system. It impacts everything else, which I think is super fascinating. So let's talk about what actually affects your gut then. So like what can throw all of this off? All right. One of them being stress, right? If you are constantly stressed, your nervous system, like I said, via the vagus nerve is going to be talking back and forth to your gut. So if you're constantly stressed, that's going to impact your brain's ability, the communication between your brain and your gut, and therefore can adjust what's going on in your gut. Your diet, your fiber diversity, your micronutrient diversity, like those different things are going to impact A, what's absorbed, and B, what's also like aiding in like how your cells are actually, like your cells within your digestive system need to be taken care of as well. And your diet and the food that you consume is going to, can have the, well, it does impact, but it can positively or negatively impact the health of those cells in addition to all the other cells within your body. Antibiotics and certain medications. So here's the deal is that some people will take medications. We have to think when we're talking about medications is that our body is a series of cascade of events. We do one thing and then the next thing happens and the next thing, it's like dominoes constantly. So if we are changing the direction of the dominoes falling in order to avoid one specific pathway, it's still, the dominoes are still going to fall just in a different pathway. So you have to think about that. So sometimes when we're taking certain medications for specific issues, they can have an impact on our gut because they're circumventing one issue that might affect X, Y, and Z part of your body, but they therefore go and affect something else, which is going to have a cascade and therefore affect your gut or your gut cells or something that affects your gut and or nutrient absorption. So it's just something to keep in mind. Your sleep and your circadian rhythm can also affect your gut and the cells within your digestive system and how they function, and environmental toxins, environmental exposure. So like molds, toxins, those different things can affect how your gut functions as well. So over the next few sessions, we're going to be talking about a bunch of different things, but next time we're going to talk about something that most people have never really been like told that really matters or really thought too much about. And that's stomach acid. So I'll see you next session.